Hello, welcome back. We will be discussing about the water treatment procedures and filtration aspect. And in this video, we'll be talking about flow-through expanded beds. Normally, what will happen during the regular operation of the filter bed will get clogged during the normal operation. So the clogging is avoided during backwashing. So here we are sending backwash water along with compressed air. So when you are sending backwash water at small velocities, the filter bed is normal. Slowly and slowly, the velocity increases, then the filter bed starts expanding. At some stage, the entire filter bed will be under fluidized state. All the particles, they will be under suspended state. So the velocities are now, we look at the upward direction, we are having the backwash velocity. And when the particles are there in the freely moving in this filter bed, in the expansion portion, and they are free to move, settle down to the bottom, is some settling velocity. So settling velocity of the particles will be in the downward direction, and the upward direction we are having the backwash velocity, which is causing the full expansion stage. At this stage, the gravitational forces, whatever are there, that is nothing but the weight of the particles, it is it should be balanced with the forces which are trying to uh, lift the particles up. At the same time, one more condition you can observe: the total mass before expansion should be same as that before expansion. Now, to see this, you can click the picture. What you are seeing is the filter bed, and this is the strainer. The water is coming with some backwash velocity. The bed is expanded. Initially, length of the bed is L and porosity is N. Because of expansion, the length of the bed is LE and the porosity is NE. So based on these fundamentals, we will try to find out some relations under this condition. The weight of the filter bed before expansion is L into 1 minus N. This is the weight of solids. Into A is the area, surface area, and gamma S is the density of solids. Weight of filter bed after expansion. This is the length of filter bed after expansion. And 1 minus Ne is again the difference in porosities after expansion. Then A is surface area, gamma is. So when you're balancing these two, 3 and 4, Le is equal to L into 1 minus N divided by 1 minus Ne. This is one relation. And another thing is when the particles are completely fluidized, then weight of water is again is one thing, and then weight of solids both are the weights which are acting here. That means the net density will be equal to gamma S minus gamma W in the downward direction. So weight of particles in the fluid state is nothing but L into 1 minus N into A surface area, gamma S minus gamma W is the net density in the downward direction. Frictional pressure drop, if you're going to calculate, frictional pressure drop is the head multiplied by the area into gamma W. This is nothing but weight of water. So now when you're balancing these two, 6 and 7, we can find out a relation where HF is equal to L into 1 minus N into SS minus 1, where SS is the specific gravity of the solids, HF is the head loss in bed. When the backwash velocity it reaches a supercritical velocity, the particles are fluidized completely. So the ultimate velocity where the entire particles under suspension. At that stage, the supercritical velocity is approximately equal to terminal settling velocity, so that they settle freely in the bed. So now we are having two velocities, one in the upward direction, backwash velocity, and another one, the settling velocity of the particles which are freely settling. We can have a relation between these two as Ne is equal to Vb by Vs whole to the power of 0.22. The settling velocity of the filtered particles in the bed can be obtained using the Stokes law given by Gd squared by 18 into Ss divided by kinematic viscosity. Using these relations, if you try to see how you are going to apply this equation to calculate the parameters of the expanded bed. A filter bed of uniform sand having a size of 0.6 mm size, specific gravity 2.65, porosity 40%, and depth 70 centimeters is to be washed hydraulically. Compute expanded bed length at expanded porosity of 50%, backwash rate, head loss in the bed. Take kinematic viscosity as 1.3 to the power of minus 2 centimeters square per second. So L, the bed length is 70 centimeters, porosity is 40%, that is 0.4. Expanded porosity is 50%, equal 0.5. Specific gravity of the solids is 2.65. Kinematic viscosity is 1.3 10 to the power of minus 2 centimeters square per second. So expanded bed you can calculate from the relation L into 1 minus n by 1 minus G. Substituting, you are going to get 0.84 meters. So initially 70 centimeters, now it is 84 centimeters. Head loss is calculated by L into 1 minus n into Ss minus 1. So you substitute all the values and you are going to get 0.79693 or around approximately 0.7 meters or 70 centimeters. And settling velocity of the particles under fluidized state, we are calculating using formula Gd square by 18 into Ss minus 1 into V, a kinematic viscosity. And substituting all this value, I'm going to get as 24.9 centimeter per second or 25 centimeter per second or 0.25 meters per second. And here, what you're having what you have to calculate is the backwash velocity. We are having the formula Ne is equal to Vb by Vs whole to the power of 0.22, or Vb is equal to Vs into Ne whole to the power of 4.545. You substitute this, we can have 0.01 meters per second. So finally, if you want to have a back check, we substitute Vb and Vs and check for Ne, it is 0.5. So this is also okay. A water filtration unit is made of uniform size particles of 0.4 mm diameter with shape factor of 0.84 and specific gravity of 2.55. The depth of the filter bed is 0.7 meters and the porosity is 0.35. The filter bed is to be expanded to a porosity of 0.65 by hydraulic backwash. If the terminal settling velocity of the sand particles during backwash is 4.5 centimeter per second, calculate the required backwash velocity, length of expanded bed and head loss. So what is given here is settling velocity of the particle, 4.5 centimeter per second, and expanded porosity 0.65, backwash velocity you have to calculate. So we are having the formula Ne is equal to Vb by Vs whole to the power of 0.22. Substitute here and then calculate Vb, which is equal to 0.635 centimeters per second. Similarly, expanded bed length L into 1 minus n by 1 minus Ne, it is around 1.3 meters. So 0.7 and 1.3, almost double. Head loss due to friction, L into 1 minus N, SS minus 1. It is substituting here, getting 0.7 meters.